Hello everyone, it's August 31st. Time flies. Alright, so today's goal is I'm gonna finish this for sure. And then I want to go through yesterday's problem. There are two methods, so I'll go through them both. And after that, I have to go through some JavaScript because I have a interview coming up. Like seriously, I have an interview coming up. And in the interview, in the job application, I said I know JavaScript. Well, I do know JavaScript, but not really, not really proficient in it. So I need to. I guess the interview will be in JavaScript and solving problem in JavaScript. So it'll be good to learn to get familiar with it. And I also lied that I have done React. Well, I did a lot of React Native. So yeah, what's the difference between that, right? React, you just do it in the web. So I mean, it cannot be you don't say it's like a real lie. I mean, I did not like say from start to end do any React, just pure React. No, I didn't do that, but I did touch a little bit. So I think what I'm gonna do is just to go through some tutorial, do some React, and have an idea for a simple app. So I just want to do that, and hopefully I'll do this within a week because I'm gonna schedule the interview sometime next week or next week. So I'll be ready. So for the next week, I will, and then including these few days, I will definitely put more emphasis on working through the JavaScript problems on LeetCode. All right. Anyway, so let's just do this first. Given and return an array answer of length n plus 1 such that for each I, answer I is the number of ones in the binary representation of I. So we get a binary. Answer I is the number in the binary representation of I. Oh. It's very easy to come up with a solution with a runtime on log n. Yeah, I mean, basically you go through on. For each one, you just count, right? Let's do that first. Let's do that. And then honestly, it's not trivial because I do not know how to convert. So I'm going to say JavaScript, not JavaScript. Java convert into binary string. Oh, that was quite simple. Okay, Java's count number of occurrences in string. No, come on. I mean, that is okay. Count matches. No, that's Apache Commons. Spring framework. Using replace all. Replace all. What is that? filter. Tokenizer. Yeah, I think the runtime will be, oh, wait, hold on a second. Direct count should always be good, right? Sooner or later, something has to loop. That is true. What is this? Be kind to your stack. Oh, this is John Skeet. Yeah, this is what's it called? Premature optimization is the source of a lot of evils. Yeah, if John Skeet says it's this way, we'll do it this way. Yep, I agree. I'm gonna just, you know what, don't copy and paste. Let's just do it your way. Okay, so we were going to do a private count occurrences, right? So we have a string str and we have a character c, right? And we do int count for int I 0, I small str the length, I plus plus. If str the char at I is equal to c, count plus plus. Nothing fancy, right? Nothing fancy. It's easy. Just do that, right? And we're gonna say int res equals to new int n plus 1, all right? Zero, 1, 0, 1, 2, 3, 4, 5. Yeah. So we're gonna say for int I equal to 0, I smaller equal to n, I plus plus. String bin binary equal to, oh, I actually forgot, how do you convert? Integer dot to binary string I, right? And then we say res I shall equal to count occurrences character. What's this character? Count a number ones. Sorry, it's not my intention. All right, now we'll return res. Okay. I think this is what we want. Oh. Let's do it this way. It'll be more fun. Okay, so let's submit it first. I don't know, probably I just did it this way and I didn't really want to make any more changes to that, but this is the naive way, right? Naive way. (338) naive method. The log n comes from the binary string. And of course this, right? So now we need to try to see if we can do it in linear time. And possibly in a single pass. Well, I mean, in linear time. Linear time? How? Huh. Linear time. Well, if you convert to binary string, that's already not linear. Okay, let's just say that is linear. Okay, let's see that is linear. Let me think. To a binary string. The number of ones. I mean, you don't even have the count. You can just divide by 2. Right? You divide by 2, divide by 2, divide by 2. And then whenever you had a remainder is 1, that's a 1. Right? I don't know. Maybe there's some mathematics involved. I mean, you want to observe, is there any, see 0, 1, 1, 2, 1, 2, 2, 3, 1, 2, 2, 3, 2, 3, 3, 4, 1, 2, 2, 3, 2, 3, 3, 4, 2, 3, 3, 4, 3, 4, 4, 5, 1, 2, 2, 3, 1, 2, 2, 3, 2, 3, 3, 4, 2, 3, 3, 4, 4, 3, 4, 4. Yeah, this seems to be. Maybe there is a. Because I know it always starts from. Yeah, I think there is, right? There is a. Yeah, let's write them out. I think there is a. Right, you start with 1. Now 1, 0, 1, 1, right? 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, and 1, 2, 3, 4, 5, 6, 7, 8. Then you just repeat this entire thing. Right? You repeat this entire thing. You start from 8. Actually, we can have a 0, right? You start from this, and then it's just gonna be the entire thing, which means when we hit 8, 8 shall equal to result 0 plus 1. 9 shall equal to result 1 plus 1. Right? Because it's 1, 0, 0, 1. All the way to 15. Right, 15 shall equal to result with minus 8. 7, which is this, plus 1. Now 16 shall equal to result 0 plus 1. So basically, we'll go through and then just see if this is a power of 2. How do we know it's a power of 2? Do we have a quick check to see if it's power of 2? Well, we can check by we can pre-compute power of 2. That's one way to go. Like the current power of 2, right? The current power of 2. Oh yeah, we can say the current power of 2 is the current power of 2. No, start with 1. So the current, we say power of 2 apart is a 1. Okay. Now when we start, because when we, so whatever value we have, we will minus the power of 2. So we start with 0. So the 0 has to be 0. So maybe we just go, you know, as n start with 1. Okay, if n start with 1 and we say current power of 2 is 1, all right, then 1 shall equal to res 1 minus power of 2 plus 1. That makes sense, right? And then we go to 2, right? Oh, we can say the current power of 2 and the next power of 2. If it's equal to the next power of 2, I'll swap. Oh, this might work. This actually might work, honestly. We can go power of 2. So we don't have to count, right? So this is going to be on. Okay, take advantage of power of 2. So we do this, right? That's fine. And we'll do res 0. I think it's initialized to 0, so we probably don't have to initialize. So we're gonna do this is 1, and we say int current power of 2 is 1, and next power of 2 equals 2. We can do that, and then what do we do is what do? We say if the current value, right, if I is equal to next power of 2, so we hit the next power of 2, then we say next power of 2 current power of 2 shall equal to next power of 2, and next power of 2 shall multiply by 2, right? And then I just say res I shall equal to res I minus current power of 2 plus 1, just 1 to the left, right? And then blah blah blah, and then we return. All right, let's try this one. Let's see if this one's good. Yep, that's on. Ooh, much faster, huh? Much faster. Was that the method I used last time? Bean count. Come on, man. This is the right way. Power of 2. Oh, look at this. Ah, this is nice. This is nice. Holy crap. Yeah, we just need to divide by 2, man. So same idea, right? But we use this minus to find whatever the previous is gonna be. But in fact, we could have just do this divided by 2. Well, it divided by 2 is like a left shift, right? We left shift. So whatever the value is, we left. Oh, ooh, I think that is the right. This is the right solution. This is the right solution. All right, so this is inspired by. Yeah, I think this is the right way to do it. For each value, we simply right shift, right? We right shift to obtain the number of one count of a previous number. Then we add the shifted, right? The last digit, either 1 or 0. Yeah. So we don't even need to do this. Okay? We don't even need to do this. All we need to do is say left shift 1 plus I mod 2. Oh. This is going to be outrageous. 1, 2, 3, 4, 5. Outrageous. Oh, absolutely outrageous. Things should be faster. Yeah. Because you don't have the if statement. Oh. I thought I got it. This is better. This is better. All right, so we have 3 solutions. We need to put them in. 3 solutions. We haven't made directory for a while. All right, we have 3 solutions. Let's go through them one by one, and we're done with this basically. So that's solution 1. Solution 2, and actually I got solution 3 here. Beautiful. Solution 3 is absolutely beautiful. I didn't think about it. Okay, so let's go through this. So what is the problem? Oh, we're trying to find a minimum to get there, to cover the entire range. And the solution we did yesterday was go from right to, we sorted first, right? And we go from right to left. And depending on the stretch, right? Depending on the stretch, we say, no, we'll go left to right, right? We'll go left to right. So what we want to do is for each stretch, we want to stretch as much as possible, right? As much as possible. Okay, so we have a DP for this. Okay, a DP. Okay. Let's see if we can get the inspiration from this. We say DPI is the minimum number of tabs to water 0 to I. Okay, I think inclusive. All right. Basically, we have a range 0 to I, and we have, whatever range we have, right? And DPI is the minimum we need to get here. Okay. So, if we want to compute DPI, right? We need to compute DPI, like we don't know this. If we have something already, right? We have the previous, right? We have DPI minus 1, minus 2, but we know all this, right? We know what is the minimum of this, minimum of this, minimum of this. We know all of them. Now this is with DPI. So I can say, right? Maybe I can find, all the ranges that covers me, right? All the ranges that covers me. Because I know cover here, right? I know. So I can do all the ranges that covers me, right? For that, I can probably binary search, but I'm pretty sure that's not what it's looking for. Or, let's keep reading. I actually don't know. That's one. Oh, DP0 is 0. That is surprising. DP0 is 0. Huh. DP0. Oh, because n is equal to 1, it's never 0. Okay, that makes sense. DP, because we are watering this range. So this is 0. Okay, I agree. DP0 is 0. For each tab, we identify its leftmost, rightmost position that can be reached and watered. The leftmost position, yes. The rightmost position, yes. Because the arbitrary position J inside the range, okay? So for that, we have arbitrary inside the range. All right, we're inside the range. If dpj taps to water the part of the garden from 0, an arbitrary position j inside the range of the ith tap. By dp definition, when dpj taps to water the part from 0 to yes. Thus, if we open these dpj tabs, We open these tabs, okay? And the ith tab. And total, we will water the part of the garden from 0 to position. Yes, that is correct. It means, okay, so that, I think what it means is, given a range, right? Given a range, if we open this tab, if it's open, then we can water any, so like any position inside here, dp this. So hold on, if we open, then they'll always, so we can say dp this and, right, dp this and to equal to dpj, yes, plus this one, plus 1, and then j goes through the entire thing. Makes sense? Position 0 is inside the range of the ith tab. This one tab is sufficient to water the garden from 0 to position. Yes, that's true. And thus dp I equal to 1. Yeah, everything in this is going to be 1. When dpj is 0, we'll update, that'll be 1. And then everything down, yes. 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 So we have to go through n, and we have to go through every stuff. Right? We have to go through every stuff. We have this target. Start to end, start to end, start to end, which means on times this range, right? Average, m is the average range. Okay, so that makes sense. Let's implement it. We'll do reset to default. So this is the DP solution. First, create all the ranges, but the left should not exceed, should not go below 0, and the right should not go beyond n. Then for each, then define dpi as the minimum number of tabs to cover 0 to I. Okay. Then for each position j in a range start and, right? dp and shall equal to dpj, right? Plus 1. Of course, minimum of dp and this. The answer is dp n if it has been computed, right? Otherwise, -1. Very simple. Okay. All right. So we have this. So we just need to create dp table. All right. dp shall equal to new int. Because we have to go to n, so n plus 1, right? And then for int I equal to 1, I smaller equal to n, I plus plus. So for each one, ranges 0, 1, 2, 3, 4, 5. I need to start from 0, but we don't do 0. We need to start from 0. Okay. Then we can count int left shall equal to math.maximum I minus 0, I minus ranges I. Okay. And right equal to math.minimum n I plus ranges I. Now we get the left and right. Okay. Now we're gonna go through this left and right. Then we say for int j equal to left, j smaller equal to right, j plus plus, right? For each one, dpj, not dpj, we say dp right shall equal to math.minimum. Oh, we need to initialize for int I equal to 0, I smaller equal to n, I plus plus, dpi is equal to integer dot max value. Initialization. So this shall be dp right and dp j, okay, plus 1. dpj plus 1, right? And then the next one, yeah, we just dp right. That's fine. That's fine. If something we haven't figured out before, we just need some on the left has been figured out. So in that case, yeah, so we shall just return. We say dpn is equal to, is smaller than integer dot max value. If it is, we'll return dpn. Otherwise, return -1. So this is OMN, where M is the average of value in ranges. Okay, so give us a shot. Do we have all the test cases? We have a few. I think we didn't include this one. Oh, we do have this one, right? I think. Yeah, we do. What the hell, man? What the hell, man? Oh, it overflows. God. Alright, we just -1 then. Well, that doesn't work. That's oof. That's go -2. Doesn't work. Oh, everything's -1. Oh. I don't know. What am I supposed to do here? I think I just need a large value, right? Just need a large value. Okay, so the largest value that can happen is depending on so the maximum is we turn on every single one, right? So this should be n+1. This is the largest possible. And then we just say if it's smaller than n+1, then we do this. Does this work? Madre mia, still not working, huh? Oh, I forgot one thing. My bad. Know that dp0 is equal to 0. And you know what? This need to be expanded because at I equal at dp0, right? Because no tab is needed to water 0 to 0. 0 length. The stretch of garden has 0 length. Yep, I think this one makes sense. Other positions are initialized with an impossible large value. Okay, we try this. This will be slow. I am surprised. Ha! This is actually faster than what I did. Well. Well, I mean, okay, I thought mine is fast. I mean, technically, it's okay. All right, now we go greedy. Leftmost position of the tabs rank be start. Okay, first we compute auxiliary array max reach. Let max reach I be the maximum end over all tabs having start equal to I. We use this array in our algorithm. So this is the max reach. So max reach I be the maximum and of all tabs having start equal to I. Yes. So if I have a start at a certain position, then we get the maximum reach. That's an interesting data structure. That is an interesting data structure. You start position 0, you can jump from position from I to the right, but not further than. That is correct. What is the minimum number of jumps to reach the position? Correct. It is a jump game too. We start with tab 0 and pointer current end. Tabs represent the number of tabs used. The pointer current end represents the position such that we have currently water the part of from 0. So okay. So basically, I think it's similar to what I want to do. I mean, you want to give us a shot. So now what we know is at a start, right? At any start. So we have a max. We have the max reach, right? So max reach I is the max reach starting from I. So basically the max jump, right? So we start from 0. So we go to 0 to find the max reach. So now we have the current reach, okay? We have the current reach. Okay, we have current reach. Then what? Then you go to 1 to see if you have a reach. If the reach is smaller than a current reach, then yeah, it's useless. You keep going. Once you find something that's more than that, okay, we go beyond. Then you say, okay, we'll do that. But so what you want to do is within 0 to the current reach in this, you go through this and you need to find a maximum, right? You go through this, you find a maximum, okay? Then you go through this to find the next maximum. That makes more sense, right? So basically we go through this part first, get the next one. Coming back up. Okay. Let's give this a shot. Let's just basically do it our way and then see if it's the same as what they want. So use a max reach array to record the max reach, the max position, max right, reachable from each start. In other words, max reach I is the max right reachable starting from I. Then the problem is converted to starting from 0 with the max reach serving as the max jump possible from each position. What is the minimum number of jumps to reach n? So, given a start and current reach, right? We go through them to find the max next reach. Then we Then we repeat the same process until the max next reach goes to n or beyond. So this is all n, right? Okay, let's do this. We need a max, and Java I think doesn't have a max. Oh, I don't need max. I'll just add. What does John Skeet says? They're always gonna be a loop, right? At a certain point, you have to do a loop. Might as well do it yourself. Okay, so we're gonna do a max reach. Each position. So from 0 we have 1 all the way to n. So this is that. And then we need to go through, right? For int I equal to 0, I smaller equal to n, I plus plus. We'll go through the ranges, right? Now we just say max reach math dot max 0 I minus ranges I. Ooh, that is not n minus n plus 1. Dude, that is not. Holy crap. This is the starting position. And you know what? That's correct. The starting position. We just need a starting position. And that is actually correct. That is correct. That is correct. Because the starting position will not go beyond n. No, it's correct. It's correct. So we go I minus, yeah, because you minus ranges I. That's the starting position. So equal to maximum reach. So we say math.maximum, right? Maximum of whatever it is. Oh, I have to do this again. All right. Left. Man, we did this earlier. Should have just copy and paste. All right, we should have copy and paste this thing. Okay, then this thing can be simplified as left. And we can say max reach left and right. Right? So the max reach start from the left will be whatever it is to this. Okay, that's good. So now we get that, right? Next we need to do is starting from 0 and we need a current reach. We say int current reach, right? Current reach and current reach, current left, current right. Okay, current left is 0 and current right is max reach 0. Perfect. And we say while and int res equal to 0. Okay, then we say while current right is smaller than n. Then we say int next right equal to 0 and for int I equal to current left I small equal to current right, because I go through all of them. I plus plus next right equal to max dot max next right and max reach I. We go through all that. Say current right equal to next right and current left equals to current right. Actually no, these two has to be swapped. We get a current left because we do this, right, all the way to this. I mean, actually, hold a second, right? And then we Go, 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 go. Then we try to find the next right? Try to find the next right. And once we go through the whole thing, so that's the next right. That's the next right. And if the next right is beyond plus equal 1, it's fine. Then we start from the current right. But the current right is already done, right? The current right is already being considered. I guess that's fine. So here is the thing. If next right is larger, is smaller, okay? Smaller equal to current right, which means it's impossible for us to go beyond. That is a bad case. Otherwise, rest plus plus, and then we do this, right? And at the end, we return rest. All right, let's give this a shot. Actually, not very confident, but I think it shall work. Does this work? Nope. We're missing. Oh, we seem to be missing 1. Oh, I think this is started with 0. We start with 1. Because the 0 to current right, that's already 1. Ah, that makes sense, right? That makes sense. That makes sense. That was good. Jumping game, right? This is jumping game. It's basically jumping game. But hold on, this should be start with 1. Okay. Not bad, not bad. The DP is actually a pretty interesting solution, but this is definitely better. Okay, let's just finish reading this whole thing. See if we had the same idea. We got this. For each step, we select the tab that can go further right. Yes. Next. This is next right. Yes. Find next end. The maximum end over the tabs having start. Yes. Interesting only if this and because otherwise there exists another tab. But with greater n, yes. We replace start with I and end with max and obtain the max, yes. After finding x, we treat it as our new current position. Select the tabs with the furthest reach. Yes, at each step we go furthest, we aim to maximize coverage. That is true. Until we reach the end. At that point, if we have tabs that cover the entire garden, return the count. However, if it is not possible to water the entire garden, we return -1. Okay. Let's see its implementation. This is fine. Start and yes, we got that one. Tabs, which is result, and they start from 0, which is fine. If I is larger than next end, they go through the whole thing one by one. Let's understand this part. So we go through everything, and next end. So we start if it's larger than, which means this current I has not been covered, right? If I is larger than the current end, then tabs yes, because we go beyond, and the current end equals next end. Otherwise, next end equals, that is good, right? That is very good. Which one do you think is better? Well, this one we just go through them one by one, and at each one we just look to the right to to see if it's possible. Next position we go. Next position, if it's within, then we don't do. If we go beyond, actually this makes sense too. So let's do an update. Let's do a solution 4 with update. All right. How did you do it? Same as solution 3, but with another looping structure from the official solution. So rest will start with 0. So mine is have the current right, next right. We just go through go through this, right? We get this, and then we compare, and then we swap. That's fine. And we need to say int current right 0, next right 0. Okay. Then we just do, you know what, this is actually very stupid because I don't have intelligence. We say for int I equal to 0, I smaller equal to n, I plus plus. We go through every single one, okay? And then we say if I is larger than next right, return -1. Right, so this is current position cannot be covered by a previous, by the next max reach. Impossible to cover. Ending at I. Alright. Then if I is larger than current right, okay, then rest plus plus. Right, we just enter the new, then we say current right shall equal to next right. Then we can say next right shall equal to max.maximum next right. So it's smaller than current right. Then we need to find max reach. Okay, run this. Jumping game. Max reach. Yeah, very stable. Right, Java very stable. Okay, okie dokie, that's all. Actually, that's not all because I said I'm gonna handle some JavaScript. So let's do some JavaScript. We have JavaScript. Just do one. What's this? Check if object instance of class. Write a function that checks if a given value is an instance of a given class or superclass. An object is considered an instance of a given class if the object has access to that class's methods. There are no constraints on the data type that can be passed to the function. For example, the value of the class could be undefined. So we want to say check if instance of input new date as object class function. The object returned by the date constructor is by definition an instance of date. Class function. Wait, hold a second. Object is a class animal, and class dog extends class animal, return. Check if instance of new dog and animal should be true. A date construct cannot logically be an instance of itself. 5 a number, true. 5 as a number, know that the instance of keyword will return false. It accesses the number, for example, to fixed. Holy crap! How do we do this? I have no idea. I have no idea. So we cannot do instance of, right? And how we do this? It says if we can access the function that can be called. What is instance of 5? Oh, this one will be interesting. I don't have. I think the easiest way. Oh, I have to do this. The easiest way to run JavaScript is. I don't know. Do they have a REPL? Wait, does JavaScript has a REPL? JavaScript REPL. What is this, right? REPL.js, Node.js. I guess I can. Let's see if we do node. Oh, instance of 5. Oh, unexpected token. No, hold on. A 5 dot. Hold a second. What are the functions again? Instance of. Wait, I cannot call instance of. I have no idea. Does this make any sense? Wait, how do we use instance of? Oh my god, this is very embarrassing. Oh, holy crap. Oh, is no. Oh shoot. How are you gonna do how are you going to do seriously, how are you gonna do the interview by this, huh? You want to do the interview in JavaScript? Man, it's good that I notice all the knowledge gap that I have. Holy crap! I want to come on, give me smaller. Okay, but still, I don't know like how we gonna do this. Well, you can do instance of, I guess. Hold on. Class animal, right? Class dog extends animal. New dog. Okay, new dog instance of animal. That is true. So I think majority of them can be handled by instance of. It's just there are situations. These should be false. Yeah, majority of them can be handled, but how do we handle this? So if it's true, then we just do true. If it's false, then we need to do more check. I have no clue. I honestly have no clue. I don't even know. It accessed the number methods. Alright, I need to go hint. I have no clue. Inheritance is achieved with the prototype chain. You can get a prototype of an object with object.getPrototype object. You can code. So are you telling me object.get just give me a nothing. 5. Just give me anything. There's nothing. That's also nothing. What? What if we do a new date? Traverse the entire prototype chain until you find a match. Just give me nothing. I don't know. Prototype. Learn JavaScript prototype. Inheritance. Anyway, I'm gonna end right here. I need to read this prototype stuff. I will see you guys tomorrow. Adios.